Hello, calculus fans. Let's say we're going to estimate the integral from 0 to 2 of e to the minus x squared dx. And we're going to use a left-hand Riemann sum. I don't actually want to compute this estimate. What I really want to do is say, if we were to compute an estimate, would it be an overestimate or an underestimate? Let's first look at a picture. Here's a graph of y equals e to the minus x squared, and it also shows the rectangles associated with a left-hand Riemann sum. I happen to pick 10 subintervals on this one. It's not really going to matter all that much. The thing we want to notice is that the approximating rectangles go above the curve. And that's because the curve is decreasing. And that means that the estimate from the left-hand Riemann sum is going to be larger than the actual value of the integral. So our estimate is an overestimate. Now, if this happened to be an increasing function and we were doing a left-hand Riemann sum, well, perhaps you should draw a picture and convince yourself that with a left-hand Riemann sum and an increasing function, we would get an underestimate. Let's try another one. We're going to estimate the integral from 0 to pi over 2 of cosine x dx. And we're going to use the trapezoid rule. Is this an overestimate or an underestimate? Now, this is really kind of a ridiculous question because we can evaluate this integral exactly. In fact, it's really easy. Let's just carry on with the problem to illustrate the idea here, because there are going to be some other problems where it's not going to be easy to evaluate the integral. And just as before, let's look at a picture. Here is a picture of cosine x on the interval from 0 to pi over 2, and we've drawn in some trapezoids. Now, it's a little hard to tell from the picture, but the trapezoids are actually inside the curve. Now, that's going to mean that the estimate from the trapezoid rule will underestimate the true value of the integral. Now, the reason that the trapezoids are inside the curve is that the function f of x equals cosine x is concave down. Now, remember that one of the hallmarks of a concave down curve is that secant lines to the curves will lie under the curve. And when we make trapezoids for the trapezoid rule, it's done with secant lines. And the last thing is we should mention that the reason that this curve is concave down is because its second derivative is negative cosine x, and that's a negative function on the interval from 0 to pi over 2. Okay, that's all for now.